Hello student, for today we're going to take a look at topic 3 which is going to be related to the Newton's law of motion. So this question is taken from the past semester midterm task question. So let's read the question here. Figure 2 shows a block of mass M1 24 kilogram on a smooth plane inclined at an angle of 30 degrees to the horizontal. The block is connected to a mass M2 which is 8 kilogram by a massless string that passes over a smooth pulley. Okay, so let's take a look at the system here. We have first of all mass 1. So this is mass 1, 24 kilogram. Okay, and then we have mass 2 here, which is 8 kilogram. Okay, hanging here, and then it is on an inclined plane, and then it is a smooth inclined plane, meaning there is no friction. Okay, so there is no friction, and then meaning that there is not going to be any frictional force. Okay, so given the angle is 30 degrees to the horizontal, and then the block is connected to another mass, okay, which is going to be 8 kilogram. This is the hanging mass, 8 kilogram. And then it is connected by a massless string that passes over a smooth pulley. So this is going to be the pulley, and then the pulley is used to change the orientation of the string. Okay, so meaning that, for example, we have this one is vertical, and with having the pulley, we're going to have a rather relatively horizontal, in this case horizontal string. So that is actually going to be the idea. Okay, and another thing that we have to bear in mind is that also we have this massless string. So the string is used to connect the two masses together. Okay, so M1 is connected to M2 by this massless string. Okay, so that's important. And then let's take a look at the question. As always, the question will ask you to draw the free body diagram of the two blocks, okay, and then ask what is going to be the acceleration of the block, and then last but not least is going to be the tension in the string. Okay, so it is important to know that for the first question, drawing the free body diagram, okay, so the free body diagram is important because we're going to write down our equation based from the free body diagram. So if you draw an incomplete free body diagram, so definitely your equation is not also going to be complete. Okay, and then we have to also understand that we need to calculate the acceleration in the second question. So if, for example, mass 1 is accelerated with this A, alright, mass 2 is also going to be accelerated with the same acceleration. Same acceleration, however, it is going to be directed upward. So if we calculate, for example, we're going to get 10 meter per second square here, right? So if this is 10 meter per second square, so relatively going upward for mass 2, it is also going to be 10 meter per second square. So the acceleration is going to be the same. Remember again, because they are connected by the string. Okay, so let's take a look at the first question, drawing the free body diagram of the block. Okay, so we're going to draw the free body diagram of the block. Okay, so we're going to take a look at the first question now. Okay, to help you with the question, I have included here from our workbook, okay, we have this list of forces. Okay, because it is important to know all of the forces that is related to the situation. Okay, so if we take a look at our question just now, we know that there is going to be no external force, because the force that is actually experienced or causes the acceleration is going to be due to the weight of the mass itself. So we're going to have the weight, okay, and then we're also going to have the normal force. The normal force happened because M1 is on a surface. So any object on a plane or on a surface, it will experience normal force. Okay, and then we have string, so definitely we're going to have tension. Okay, and then moving on, number 5, we don't have friction force. As mentioned in the question, the pulley is frictionless, the plane is also frictionless. We don't have any spring, so there is going to be no elastic force. Okay, and then definitely 7 and 8, there is no electric as well as magnetic force. So with the three forces, okay, that has been listed here, we tick the three forces here. Let's draw the free body diagram. So let's start with the first one, which is mass 1. So this is going to be weight of mass 1, W1 is equal to M1G. You can calculate this by knowing what is the weight of mass 1, which is 24 kilogram. Okay, 24 kilogram, and then you multiply with 9.81. So mass 1 is going to be equal to, right, it is going to be equal to 235.44 Newton. Okay, and then we're also going to have another force, which is going to be the normal force, and then the normal force is going to be 90 degrees, okay, with the plane, okay, of the surface. It is going to be 90 degrees with the plane of the surface. Okay, and then moving on, we also going to have the tension, and then the tension is going to be directed parallel to the plane. Okay, or we can say that the tension is inside of the string, so this is going to be the tension T. Okay, and then we know that the acceleration, I'm going to draw it with a different color here. The acceleration, as mentioned, it is going to be relatively downward, or down the slope, or down the incline. Okay, and then with that, it is important to change the orientation of our x and y axis. To simplify it, so this is going to be our x and y axis for mass 1. So that the reason is so that acceleration is only on the x-axis. Okay, so moving on now, we also going to draw another two forces, which is going to be the force for W1, or weight 1 here, which is going to be W1Y, and then another one is going to be W1X. Alright, so the acceleration is going to be caused mainly by the weight of mass 1 on the x-axis. Okay, but then again, it will be counterbalanced by the tension. Okay, the tension is going to have opposite direction of the weight. Okay, so that is our first free body diagram, but again, you can draw it. Okay, so normally I'm going to draw an outline here, and then I'm going to repeat all of the process. Always start with the weight, that is the easiest one, and then we have the tension along the string. We have the normal, it must be 90 degrees to the plane, and then draw the acceleration. Alright, so this is going to be the acceleration, and then with that, we need to change the orientation of our x and y axis, okay, to simplify it, because if not, everything is going to have both x and y component, okay, especially the acceleration as well. So with that, we're going to now draw another two forces for the weight, which is the weight on the x component and the weight on the y component. So you have to resolve this according to the angle. Okay, so for this one, we can check it is going to be 60 degrees. So we can put it here. It is going to be, I'm going to use a different color here. So this is going to be 60 degrees. So in order to get W1x, it is going to be W1x is equal to W1 or M1G, which we calculated 235, and then cos 60 degrees. So this is our first free body diagram, and we're going to be using this to solve the questions, okay, to calculate the acceleration. And now we're going to proceed to the second mass, which is the hanging mass. Okay, so again, we repeat the process by drawing the weight first. W2 is equal to M2G, and then the mass for the second object is going to be 8 kilogram. All right, and then we also have tension. Remember, tension is always directed away from the mass. Okay, and then we also have to draw the acceleration, and then because mass 1 is moving relatively downward, so mass 2 is going to be moving upward direction. Okay, so for mass 2 again, you can draw. I always start with the outline, okay, and then this is going to be the string, and afterward draw the weight first, W2, we have the tension, and we also need to draw another force, another one, which is going to be the acceleration. So we have drawn all this, okay, and then now we can proceed to the next question. Okay, so now we're going to take a look at the next question, which is calculating the acceleration of the block. Alright, so we want to calculate the acceleration of the block. So for this one, we need to use the laws of motion. Remember the laws of motion. Okay, so I'm going to recall back the first free body diagram. Okay. Okay, so I'm going to recall back the first free body diagram for mass 1. Okay, so this is the free body diagram. Okay, so now we have to resolve it into two components. Okay, into two components. So we're going to start firstly with the x component. So we're going to start with the x component. Okay, and then for the x component here, as you can see, we have the acceleration. So we're going to be using the second law of motion. Total force is equal to ma. So just write down the formula, okay, which is total force. The summation of force is equal to mass multiplied with acceleration. Specifically, this is for mass 1. Okay, so since we have written down the Newton's law of motion, okay, so now we're going to list down all of the forces on the x components. In total, there are 2 forces on the x component, which is going to be the tension, and then we also have W1x here. So we write down the total forces, okay, on the x component, W1x, and then we also have tension. But remember, because we are adding forces, we need to make sure to include, okay, the sign as well, because the sign shows the direction. For the tension, it will be positive because it is the directed in the same direction as the positive x direction. Okay, so tension positive. However, the weight one will be negative. And then again, because we are adding them, because the sign here is summation, so we add all of the 2 forces together, and then m1, and then also put in the signs for the acceleration, which is going to be negative a, because a is to the left. So with that, we're going to have the formula to be negative w1x and then plus t, okay, plus with positive t, and it is equal to negative m1a. So we write down the full formula for w1x, which is m1g cos 60 degrees plus t, and then it is equal to negative m1a. So now we can write down or substitute the value. It is going to be negative 24 times with 9.81, and then cos 60 degrees plus t, and then here we put negative 24a. So this one can be further simplified by writing down negative 117.72 plus t, and then it is equal to negative 24a. So as you can see from this equation, so I'm going to put, okay, as a function of t, t is equal to 117.72 minus 24a. So this is going to be our first equation. We cannot find the acceleration just yet because we have 2 unknown here. The tension is unknown, the acceleration is also unknown, and with that, we need to introduce another equation. Okay, so the other equation will come from the second free body diagram. Okay, so we're going to take a look now at the second free body diagram. Okay, so we have the first equation and then we need to introduce the second equation because we have two unknown in the equation. Okay, that is how you solve the solve equation simultaneously. Okay, when we have two unknown, so we need to have two equations so that we can eliminate. Okay, and then with that, okay, we're going to take a look now at the second free body diagram. So for the second free body diagram, this is a lot easier because there is only going to be a single axis. Okay, so for this one, okay, we're going to only take a look at the y component. Okay, so for the y component here, we see that there is acceleration, so we use total force is equal to ma. So for this one, we don't need to change or tilt our x and y axis because the acceleration is exactly on an axis, which is the y-axis. Okay, so with that, that is why we use the second law of motion. Okay, so there are two forces here. Tension, we put positive because it is upward, plus with W2, it is downward. That is why we put negative. And then the acceleration is also positive because it is upward. Okay, so afterward, we put T minus M to G, and then it is equal to M to A. So T minus with M2, mass 2 is 24 times 9.8, sorry, mass 2 is only 8 kilograms. So we're going to put 8 times with 9.81, and then it is equal to 8A. So T minus with, here it is going to be equal to, all right, 78.48 is equal to 8A. So now we have the second equation. So what we have to do next is we're going to combine the two equations together. Remember, we have the first equation, okay, from the first free body diagram. So I'm going to bring that to the other slide. Okay, along with, okay, the second formula or the second equation. Okay, so for the second equation, okay, we have the second equation to be this value. Okay, so we're going to put it together, okay, on a slide here. All right, so what happened is you can use the first equation and then substitute it into the second equation. So it will be 117.72 minus 24A and minus, okay, 78.48 equal to 8A. So as you can see here, we need to combine or solve A with A. So I'm going to bring A to the other side. It will be 8A plus now with 24A. And then we solve, okay, the value of 117, okay, 0.72 minus 78.48. We're going to get the value to be 39.24. So in the end, the acceleration is going to be 39, okay, 0.24 divided by, if you cannot see, okay, and then divided by 8 plus with 24 here, and then the acceleration is going to be equal to 1.226 meter per second square. So this is going to be the correct final answer for the acceleration. Okay, so that is how you calculate the acceleration, and then definitely you can calculate what is going to be the tension in the string. Okay, so it is important again to draw the correct free body diagram, and it's not that difficult. Always look at your list of forces, cancels unnecessary forces, irrelevant forces, okay, and then just choose the forces that is relevant to the question. So that is why we list down all of the forces in our workbook, okay, and then draw the free body diagram correctly, okay, so that you can actually create, okay, the, in this case, create the correct formula according to the free body diagram. Okay, so even though we use X component, we can also proceed with the Y component for Mass 1. Alright, but the tip here is that the Y component normally is related to friction force. Since the question doesn't have friction, we can neglect the Y component. But if we want to still apply the Newton's law of motion on the Y component here, we still can. And then now we can focus only on the Y component. There is no acceleration on the Y component, so the force is going to be equal to 0. Total force is going to be equal to 0 because if we remember back, the acceleration is only on the x-axis. Okay, only on the x-axis. Acceleration is only on the x-axis. So there is no acceleration on the force. Oh, sorry, there's no acceleration on the y. So with that, total force is going to be equal to 0 or the first Newton law of motion. So normal is going to be positive plus with negative W1y, and then it is equal to 0. So in the end, normal is equal to W1y, and then normal is equal to W1, which is M1G, and then we're going to use sine 60 degrees. So this is the equation for the Y component. So we get what is going to be the formula for the normal. So now let's proceed to the last question, which is calculating the tension in the string. So definitely you can use either equation 1 or equation 2. So let's choose the first equation, which is T is equal to 117.72 minus 24a. So since we already obtained the value of the acceleration, remember it is equal to 1.2, okay, 1.226, okay. So 24 multiply with 1.226, so you're going to get the tension is, okay, minus with, alright, it is going to be 29.42. So the tension is going to be 88.3 Newton. So this is going to be the correct final answer. Okay, so that is the idea on how to solve question related to Newton's law of motion. So the idea here is actually, if you can see on the animation, right, so as you can see here, we have, okay, I can pause this, okay, so what happened is we can refer to the incline, okay, and then the incline definitely is going to affect the acceleration, okay, and then we can refer this as the weight. This can be referred to the weight, okay, and then we also have another one, which is going to be the friction force, okay. The friction force is going to be the opposite direction, okay. So that is the idea, okay. And then if we refer to this diagram, this is also a good animation. So as you can see here, okay, so initially, if it is not tilted, it is just on a flat surface, what happened is, on a flat surface, it doesn't have this green colored arrow. So if you can see here, what happened is, this is when there is no incline, okay. So when there is no incline, we only going to have weight and the normal force. However, okay, if we start to have the incline here, so now we're going to have two component of the weight, okay, which is going to be Wx, and another one is going to be, here is going to be Wy. So that is actually going to be the idea, okay. So I hope you can go through the question again, okay, and then try to solve other examples and then apply what I have shown you in the video here.